All right, hello everybody. So we are going to finish 6-1. So there's just a few other things we're going to do. So we've seen how to calculate some. I just want to show you a couple by hand. So what we would do, use a calculator to find, let's say, in decimal degrees. And this is, say, sine inverse of negative 0.133491122. And they give a bunch of decimal places. We'll just do 4. Okay. So what we would do, you just want to make sure that your mode, when you go to mode, since they're asking for it in decimal degrees, that you got degree highlighted. And then I would just do second and then their sine inverse and type in that number, and then we're just given this. It's automatically going to give it out in degrees. Okay. So negative 7.671, let's round up to 4 decimal places, degrees. So that's the angle in degrees whose sine is that value. Okay. Then the other problem that you might have is use a calculator to give the real number value. And for that, I got arctan of 1.11111. Now, only difference is if it says real number value, or honestly doesn't say anything. If it doesn't say anything, you're going to be in radians. Okay, just telling you. They really have to tell you they want you to be in degrees. So if they don't say anything or they say real number, then your mode has got to be on radians. And then you're going to punch this in. So we're going to do arctan is tangent inverse on this of 1.1111. Done. Enter. 4 decimal places, you should have 0.837. Well, we're rounding up to 4 will give us this. Okay, so that's putting it on a calculator. That shouldn't be too bad. Okay, just a couple more. And the only reason I'm doing this is because it will come up in calculus once or twice. Of course, when you use it there, you're probably going to review it. Probably may not remember what we're doing right now, but just so that you maybe have sort of seen it before a little bit. Let's say we're trying to do this. So this 77 right here, where it says tangent of arc cosine of 3/4, and it says give the exact value. Okay. So with this one, arc cosine of 3/4, I don't know what that is. Okay. Because it's not on the unit circle. You know, there's no angle who gives out a cosine whose angle is 3/4. So it's some number. I don't want to put it on a calculator, but yet we're told we can find the exact value. So it's kind of an interesting problem. What you would have to do is you have to think about the inverse trig functions as angles. So see this arc cosine 3/4 right here? The key is to think about it as an angle. Because ultimately, that's what this output is. This arc cosine of 3/4 is some angle. So I start by taking that arc cosine of 3/4 and saying it's going to give me some angle. And you can use any angle you want. Let's say theta. Right? Now, what does this mean? Arc cosine of 3/4 equals theta. This means that, literally, by definition, it's the cosine of theta, the the cosine of the angle theta is going to give me 3/4. Right? That's really what we were thinking about in the last section, just to give you an example. Like if I had arc cosine of, or I should say earlier in this section, like if I had arc cosine of pi over 6 was, say, √3/2. What that really meant was that the cosine of √3/2 was, sorry, I wrote that backwards. Arc cosine of √3/2 is pi over 6. What that really meant was that the cosine of pi over 6, that angle in radians, was √3/2. Okay? So there's this kind of definition here. And I could do that with any of these other inverse trig functions, which is what we're going to see. Okay? So, point being, this arc cosine 3/4 equals theta, I can say, well, that's the same as cosine theta equals 3/4. That's what we're really saying there. And then after that, we make a picture. So I draw a right triangle. And this is my angle theta. Cosine is adjacent over hypotenuse. So I got 3/4. And then I can also go through and say, find this other y value right here. So 3 squared plus y squared equals 4 squared. And so I got 9 plus y squared equals 16. Y squared is 7, and this is going to be positive, so I've got square root of 7. Okay. So now that I have that, then I can go back to this. Well, what is this? Well, arc cosine of 3/4 was theta, right? That's what we said it was. So this is really just the tangent of theta. Right? This is equal to theta. So I substitute that in. What's the tangent of theta? Now I use my picture. Well, tangent of theta is opposite over adjacent. So this is just √7/3. And that's it. Exact value. If you punch it in a calculator, so you have that multi-view, you punch it in, it's going to give that. You are going to have some kind of test where you're going to have to write out your work. So just to kind of clue you in, it's not going to be this week, but probably next week. Once I get through chapter 6, I do want to have some kind of test, and I think it's not going to be on Alex. I think I'm just going to send you a copy of it and fill it in and send it back to me. And it's going to be kind of format at your own pace, finish it, and send it in. Okay? I know that's not ideal, but it's kind of what I'm thinking. All right, let's look at another one with that, just to kind of get the hang of this method. Okay, so let's look at, say, 78. And this one we're doing sine of arc cosine of 1/4. Okay. So again, I look at the part with the inverse trig function. That's this arc cosine of 1/4. I let that be some angle, let's say theta. And then what does this mean? Well, this means that the cosine of theta is 1/4. And then I make a picture. So I have this right triangle. This is our angle theta. And cosine is adjacent over hypotenuse. So I have this. I go through and find this value. So I got 1 squared plus y squared equals 4 squared. And then I've got 1 plus y squared is going to be 16. So I've got y squared is equal to 15, and then y is going to be square root of 15. kind of going back to this is a sine. So this is going to be the sine of arc cosine of 1/4 was theta. So this is the sine of theta. And that value is opposite over hypotenuse, so radical 15/4. And that's it, exact value. Okay. I think what I'll have you do, here's one to have you try, okay? So I think using kind of the method, I'll get you started. And then why don't you try this one, and then I want to do one other harder one, and then I think we're going to be done. So try this one here. This one is 80 secant of sine inverse of negative 1/5. Okay, you can pause the video if you want, but go through and try to find what that value is. Okay, pause it if you haven't yet. Okay, so I'm going to go through the solution now. So I would let the inverse trig function, that sine inverse of negative 1/5, I'm going to call that some angle theta. What does the sine inverse of negative 1/5 equals theta mean? That means the sine of theta is negative 1/5. You would draw a picture. So here, I got negative 1/5. Really, all this is saying is that, and really, if you want to think of it this way, of my two possibilities, whether I'm in quadrant 1 or 4, my triangle is kind of in my quadrant 4. So I want to think about the y value as being negative, and this as being 5. Okay? And then I go through and find my x value. So I've got x squared plus negative 1 squared is equal to 5 squared. X squared is equal to 24, and I take the square root of that. So that should give me a square root of, see, 4 times 6, that's 2 root 6, right? And that was my angle theta. This time that really is my angle theta. It's not going this way. It's actually this clockwise negative angle here, whatever it is. And then replace this. This would be the secant of theta. Cosine's adjacent over hypotenuse. Secant's going to be this over this. So hypotenuse over adjacent. And I would just rationalize that. Root 6 over root 6. That would give me root 6 times root 6. 6 times 2, that's 12. Okay. And it is positive. Cosine is positive in quad 4, so that's perfectly fine. Okay, so that's that one. All right, let's do one more for fun here. Let's say we were trying to do this. So this one is 97, right, as an expression in u. And this is actually something that we might need, okay? So this is sine of arc cosine of u. So the idea here is, later on, we're going to try to take something called a derivative of a function. And it's easier for it to be as something called an algebraic expression. Algebraic just means that it's built up of square roots, rational expression dividing. So basically like rational functions, but you can also take some square roots in there. You know, like something like x cubed over 4x to the fourth plus 5. That's a rational function. Basically, I don't have trig functions in there is what I mean by an algebraic expression. So like the sine and arc cosine, those shouldn't be there. It's just going to be some expression used, some rational expression. Algebraic expression would be the term we would want to use. Okay, so to do that, I do the same thing. Arc cosine of u is some angle, right? So our cosine of u is, say, theta. That means that the cosine of theta is u. And I make a picture. So here's theta. Now here it's just u. It's not a fraction, so I could think of it as u over 1 if I want. So this is really adjacent over hypotenuse. I would need to go through and find what this is here, and I can call it anything I want. Maybe I'll just call it y, but I would need to go through and find that y value. So I would have u squared plus y squared is equal to 1 squared. So I have u squared is equal to 1 minus y squared. And then I would take the square root of that. Sorry, I don't know why I get. Okay, sorry about that. I meant to go through and solve for y, and not u. So I want to go through and solve for y in terms of u. So I got y squared equals 1 minus u squared, and I take the square root of that. So I get y in terms of u because I want everything in terms of u here. So this is really just square root of 1 minus u squared. Okay. Now, that's kind of our first part. And then once we have that, our cosine of u is just theta. So this is really just sine of theta then. And what is the sine of theta? Well, that is 1 over the square root of 1 minus u squared. And you can rationalize that if you want to. You don't need to, however. And that was number 97. Well, I think you can see my mistake here. Why did I write? I'm getting tired here. Sorry about this. This is like 11 o'clock at night here. Okay. This is this. Sorry about that. Opposite over hypotenuse. Why did I write it like that? Okay, this is our expression that we want. Now, I've gotten this thing in terms of u entirely. Okay. So we've seen that once it gets past 11, things go badly for me. Okay, that's an old person. Okay, I don't know if you've ever seen that movie Gremlins, but yeah, you don't feed them after midnight, right? Is the rule. Occasionally break that rule, but okay. So that is another one. I might give you one like that as well in the homework, but hopefully this week goes pretty well.